Okay, this is part 2, Unit 12D, and we've just talked about some concepts of redistricting, drawing maps, and now we're going to decide whether the following statements make sense, and whether it makes sense or not, and explain our reasoning. So, number 7 says, in the last election in my home state, 48% of the people voted for a Democrat, and Democrats won 65% of our state's seat in the House of Representatives. When we looked at that map drawing for North Carolina, this is very possible. So this makes sense because districts can be drawn. So districts can be drawn to favor one party or another. And again, I'll refer you back to that example of North Carolina that we looked at as far as how this could be possible. Okay, the next one, polls show that half the voters in our state plan to vote for Democrats in the House of Elections. Therefore, I can definitely expect half of our representatives to be Democrats. Okay, this one does not make sense because, again, that example we showed before, just because you expect 50% to vote for one party doesn't necessarily mean that 50% of your representation is going to come, even if it does turn out that 50% vote for one party. It's all dependent upon, not all, but it's pretty dependent upon those maps. Because again, if you're drawing the maps and you have for example, a highly populated Democrat area or a highly populated Republican area, if you draw the map so that that highly densely populated area is all contained within one or possibly two districts, then those are going to have a lot of votes in favor of the candidate where that higher population density is, but then it will kind of take out on the other side. And we'll look at some examples of that mapping, or how some of those maps may look towards the end here. But again, doesn't make sense if you have 50% of your voters to assume that half your representatives are going to follow that. Okay, so now we're going to look at some redistricting. Okay, this is from the 2010 census, led to the loss of 2 House seats in New York and Ohio. So this is due to population. The loss of 1 House seat in Pennsylvania, the gain in Florida and in Texas. So again, this just means that there was a shift in populations. So when they reapportion, some states lost, some states gained, because we stick with 435 representatives in the House of Reps. So consider the following approximate vote counts for all of the districts in 2010 before the redistricting and 2012 after. And all these figures are in the thousands of votes. So first we're going to find the percentage of voters that voted for Republicans and Democrats. And we're going to look at New York here, where New York lost a couple of seats. So in Part A, the percentage of people who voted Republican and Democrat. So if we look at Republican in 2010, again, these are in the thousands, but 1854 voted for it out of the total, which is 1854 plus 2601. Okay, so this gives us, when we multiply this out, it's approximately 0.417, or about 42% voted for Republicans. So then Democrats are just going to be the complement of that, or the remainder, we assume. I mean, there could be people who vote independent or vote for other parties. We're just assuming the two parties right now, so 58% for the Democrats. And that would be found by just taking 2601 and dividing it by 1854 plus 2601. So the amount of Democrats over the total. So that's the percentages in 2010. So now if I switch over and I go to 2012 in blue here, okay, the Republicans, they had 2,252 out of, again, the sum here, the total population. So it looks like for them were about 0.353, which is approximately 35%. So that means the Democrats will just be 100% minus 35% or 65% voted Democrat in 2012. Okay, Part B, find the percentage of House seats that were won by the Republicans and Democrats in 2010 and 2012. So when we look at the seats, Republicans were 8 out of, and then there's 29 seats, 8 plus 21. So this would be 8 out of 29. And that's about 28% when I do that out there. So the Democrats won about 21 out of 29. Well, they won 21 out of 29, which is about 50. Whoops, not 52, 72. 72%. So we can see there that in 2012, Republicans had 42% of the vote, but only 28% of the representation. So you can see where those numbers, they're not always one-to-one. And probably should have kept my color coordination going here. But in 2012, Republicans, they lost the 2 seats, so it would be 26 out of 29, which is about 22%. And the Democrats won the remainder, so 21 out of the 27 seats, because again, New York lost a couple of seats, so that's about 78%. So we can see in this one, the Democrats, they did increase over the 2 years, and so we see an increase there. So that did follow. And the Republicans, we saw a decrease in the amount of votes, percentage of votes, and a decrease in representation. But again, those aren't a one-to-one correlation there, as far as 35% voted Republican, but only 22% of the representatives were Republican. So that's dependent upon those, the distribution of those mappings that they put together. So the census did have an effect, but it wasn't necessarily a huge effect, because again, we saw that increase. The Democrats increased by so they went from 58 to 65%, 7% increase, 72% to 78% in representation. So it was pretty close when we look at that. So the district's mapping didn't have a tremendous effect based off of those who voted Democrat, and because it increased, and then the increase in those who or those representatives that they had. So that's a look at how you can check these numbers. It's not always going to work out this way, but this is just how you would look at this process. Okay. Just check my time here. Okay, we're doing good. So this next question, so we're going to consider the following demographic data for a hypothetical state. In each case, we're going to answer the question. Assume that everyone votes on party lines. So if they're a Democrat, they vote Democrat. If they're a Republican, they vote Republican. So part A here. So we've got 12 representatives for this particular state. Population of 8 million, and it's split right down the middle, 50-50, Republicans versus Democrats. If the districts were drawn randomly, what would be the most likely distribution? Well, you would just expect that 50%, 50% times 12 is 6, so you'd expect 6 Republican representatives, and also 50% of them would be Democrats. So 6 Republicans and 6 Democrats is what you would expect if everything was randomized. However, if the districts could be drawn without restriction, so unlimited gerrymandering, what would be the maximum and minimum number of, in this case we're going to look at Republican representatives who could be sent to Congress and we're going to explain how these results can be achieved. So when we go through and we look at the maximum here for Republicans, well, we're going to take the total population, which is there are 8 million people, and we're going to divide that over 12 representatives to find out how many representatives should be representing each district. So this is, and I'm going to say approximately, round up to the nearest person, so it's 666,667. So this is kind of people per district. So if that's the number of people in each district approximately, then to win, okay, you need to have, so I'm going to take that population, you need to have half of the population, and then I'm just going to tack on an extra 1 because you got to win by at least 1 vote. So if I take this, cut it in half, and then add 1, you would need 333,334 approximately people to win. Because again, +1 is so that you're not exactly half, you're not split 50-50, you have just 1 more vote than the other party. So this is kind of the minimum amount of people needed to win a certain district. And so if everything is homogeneous, and we've got this equal representation assumed because we're trying to maximize, so this is in the best possible scenario, then we need that many people to win, that many votes to win in each district. So again, the Republicans have 50% or half of the population, so that's 4 million people. And if I take 4 million and I divide it by my 333, the number I need to win, okay, this gives me 11.99, and so that means we'd be able to win 11.99, or that's not quite 12, so we have to round down. The maximum we could win would be, for the Republicans, would be 11 districts, because you have to round down, because 11.99 means we didn't quite eclipse 12, so it's got to be 11 districts won. So that's the maximum. Now, in order to find the minimum, okay, we would have to find what's the maximum number that the Democrats could win. Well, when we look at if we look at the max for Democrats, it's actually going to be the exact same number because their population is exactly half. So we do the same calculation here, and it would be 11.99. So the max for the Democrats is going to be not 12, 11. Again, there. So 11 is the Democrats' max as well. So if the Democrats' maximum is 11, then the minimum, so the minimum for Republicans is going to be the total seats minus the maximum for Democrats, which is 1 district. Excuse me, the minimum, that's what I meant to say there. So the minimum for Republicans is we take the max of the Democrats can win, and we subtract that from the total number. So 1 district is the minimum that could happen, 11 is the maximum, and then most likely the scenario is going to be somewhere in between there. But that's a look at how you would determine those. So that'll wrap up part 2, and we'll finish up with a part 3.